Hi folks, we're going to take a look at the solution to number 18b on page 185. So here they ask us to solve this system of equations. Okay, so here we see two equations, two unknowns, and we also notice that these are not linear equations. So hopefully though one of our methods from the past will help out. Here I take a look, I don't see any way to bring an elimination, so I'm going to have to go to substitution. Before I actually go to solving this system, one really nice thinking question might be try to write a geometry problem that can be solved using this system of equations. Okay, and one thing I notice when I look at number one, anytime I see x squared plus y squared equals something, that makes me think of Pythagoras. Okay, so here you have the two non-hypotenuse sides, and the sum of the squares equals the square of the hypotenuse side. Okay, and here when I see two numbers being multiplied, makes me think of the area of a rectangle. So if I take that perspective that I've got a rectangle here, and if x and y are the side lengths, well, the area is going to be 0.5. Okay, and then here, if I think of number one as representing Pythagoras, I see that the diagonal is going to be equal to 1 unit. Okay, so we see that this system of equations is equivalent to solving for the dimensions of a rectangle whose area is 0.5 and whose diagonal is equal to 1. Okay, so let's go ahead and actually solve the problem here. So I want to isolate one of the variables, and I definitely don't want to work with number one because it's going to involve taking square roots and get ugly fast. So I'm going to start with equation 2, and I'll isolate y. And so here we have y is equal to 0.5 over x. Okay, and I can even rewrite that as 1 over 2x. Okay, so I write 0.5 as 1 over 2. So now I'm going to do what I always do with substitution, and I'll take this expression, and wherever I see y in the first equation, I'm going to replace it by 1 over 2x. Okay, so 1 over 2x squared is equal to 1, and now I've got an equation in one variable that I can solve, and it looks like it's a rational equation. So let's go ahead and use our methods for doing that. So first I'll simplify this here. So 2x all squared is 4x squared. Okay, equals 1. And I'm going to solve this by multiplying both sides of the equation by 4x squared. Okay, so I'm going to clear out the denominator there. So here 4x squared times x squared is 4x to the 4, plus this just ends up being 1. 4x squareds cancel out, and here I've got 4x squared. Okay, so I've turned this rational equation into a polynomial one. Okay, and of course we keep in mind that x can't be equal to 0. So now bring everything to one side of the equation. So 4x to the 4th minus 4x squared plus 1 is equal to 0. And I'm going to try to factor this left-hand side. Now again, while this is a quartic, I also see that it's a trinomial. So I'm going to see if I can factor it as a trinomial. And it actually looks pretty promising. Because here, if this actually is going to kind of looks like a perfect square. Because here I got a perfect square at the beginning and at the end. So let's see if that works. So if we make this 2x squared and 2x squared, 1 and 1, we realize that we have 2x squared and 2x squared. Yep, that'll help me get to negative 4x squared if I just put subtractions there. Okay, so the factorization of the left-hand side is just 2x squared minus 1 all squared equal to 0. Okay, and of course this means that we need what's inside that bracket to be equal to 0. So 2x squared minus 1 needs to be equal to 0. So 2x squared equals 1. X squared equals a half. And then of course, please remember that when you're taking a square root, both sides of an equation, we have both the positive and negative square root. That would be an answer. Okay, and here I can simplify this plus or minus 1 over square root of 2. Okay, now you can also rationalize the denominator. Okay, at this point here I won't. It's not too important. Now of course, if I was relating this to this geometry problem, I wouldn't be including x equals negative 1 over root 2. Okay, because I wouldn't be accepting negative answers. But since this was posed as a straight math question, I have to consider both answers. And so now I can just solve for y. Again, I'm just going to use the easiest of the equations. Y was 1 over 2x. Okay, so y is equal to 1 over 2 times 1 over root 2. Okay, or y is equal to 1 over 2 times negative 1 over root 2. Okay, but let's actually simplify this a little bit. So here I have dividing a fraction, so this can be written as root 2 over 2, and this would just be negative root 2 over 2. But take a look at these expressions here for y and that expression for x. If I actually do rationalize the denominator here and I multiply numerator and denominator by root 2, hey, what do I get? Just positive or negative root 2 over 2. So it looks like, if I look at it as a geometry problem, okay, it looks like the rectangle that's going to have these conditions on it, area of 0.5 and diagonal of 1, is actually going to be a square with side lengths 1 over root 2. Okay, so let's now just recap, because it's a couple of times now we've seen a system of equations where they're not necessarily linear. And I hope you've noticed that substitution ends up being the one that works. Okay, so while elimination is usually the go-to one for linear equations, when it comes to nonlinear equations, using substitution is usually the way to go. Okay, that's it for this one.